Hi friends, today we are going to distinguish between different types of amines. So amines are of different types like primary, secondary, tertiary, aliphatic, aromatic. So how can we distinguish these amines by using some chemical test? That's what we are going to discuss today. So let's start with the first test, which is called the carbylamine test, and it is used to distinguish between primary and secondary amine. And the test is like this: if you take a primary amine, say for example RNH2, and this is on reaction with the chloroform and an alkali, we get RNC as a product. Means NH2 is replaced by NC functional group. NC is isocyanide. Alkyl isocyanide is a product. And this alkyl isocyanide has an offensive smell. Offensive foul smell is there. So using that smell, we can understand the product formation. So this product is getting only if it is primary amine. But when you take secondary amine R2NH and do the same reaction, you will not get the observation like this, which is no characteristic observation. This is how we can understand whether it is primary or secondary. So this is general. I'll give you an example. How can we distinguish methylamine and dimethylamine? Methylamine is CH3NH2 and dimethylamine is CH3 twice NH. So the first one is primary and the second one is secondary amine. So when you do the same test, carbylamine test, adding CH3, CHCl3 and KOH, we get CH3NC for methylamine and it has an offensive smell. But the same reagents, if we are adding to a secondary amine, we will not get the observation, so we can write as no characteristic observation. So this is how we can represent the reaction. The name of the test is to be written like carbylamine test. Got it? Now the second type. The second type is how can we distinguish aliphatic and aromatic amine. Aliphatic is RNH2 and aromatic is ARNH2. How can we distinguish? Here we can use the test azo dye test. So for azo dye test, we need to have a diazonium salt. So first we need to prepare diazonium salt by using diazotization method. Diazotization is adding NaNO2 and HCl, this mixture, to an amine. If it is aliphatic amine, we can write as RNH2 plus NaNO2 and HCl. We get Rn2 plus Cl minus. This is called a diazonium salt. And it is produced from alkyl amine, so it is alkyl diazonium salt. And this alkyl diazonium salt is highly unstable, so that whenever it is produced, it is changing into alcohol, ROH, by eliminating nitrogen. Got it? But if it is aromatic, ARNH2 or C6H5NH2 like aniline, do diazotization, then we get C6H5N2 plus Cl minus. Here instead of this R, it is C6H5. That's the only difference. And this is aromatic diazonium salt. And aromatic diazonium salts are highly stable due to resonance. Resonance stabilized structures are there, so that it is highly stable. So that you take benzene diazonium chloride and add C6H5OH phenol to that. So you will get the product like this: C6H5N double bond N. So this is as a result of coupling reaction. Detailed reaction I'll be discussing in another video. It is like this only. This chlorine will be eliminating with one hydrogen from the benzene as minus HCl. Elimination of HCl molecule. So N double bond N after C6H4 then OH. So this is a compound with N double bond N. This type of compounds are called azo compounds, and it has a characteristic color and which is orange in color. And this is a reaction which is used to produce dyes and all. So it is an orange colored dye. So when we do this test, if it is aromatic, you will be getting an orange colored dye. But if it is aliphatic, you won't be getting any characteristic color in the product side. So this is how we can understand whether it is aliphatic or aromatic. I'll be discussing a question here. Aniline and benzylamine. Aniline is C6H5NH2. It is completely aromatic amine. But benzylamine is C6H5CH2NH2. Here NH2 is not directly attached with the benzene ring. It is attached with another carbon atom. Means it is connected through another carbon with the benzene ring. So that it's not completely aryl. It is half aryl and half alkyl. This is completely aryl, aromatic. So in this case, the first one, aniline, first you do diazotization. Add NaNO2 and HCl. You will get the intermediate like C6H5, N2 plus Cl minus, which is the stable diazonium salt. Then it is on reaction with the phenol. The second step is the coupling reaction. First step is diazotization. So you will get that azo dye or orange dye you will get. Double bond and C6H4OH. So orange dye. But if it is aliphatic, do diazotization, NaNO2 and HCl, when you add to that, you will get C6H5, CH2, that NH2 will be replaced by N2 plus Cl minus. This is the diazonium salt. Since it is not completely aromatic, it is less stable, or we can call it as it's unstable. So that nitrogen will be releasing and changing into alcohol, C6H5, CH2OH, benzyl alcohol. So this reaction can be used as a conversion as well. How can we convert benzylamine to benzyl alcohol? Do diazotization first and then removal of nitrogen, we get benzyl alcohol. This is how we can understand the presence of aliphatic or aromatic amine. Third reaction, how do we distinguish primary, secondary and tertiary? All the three amines, if it is there in the question, how can we understand? That is by using Hinsberg reagent test. Hinsberg reagent is a common name, but its chemical name is aryl sulfonyl chloride, and this is the structural representation. C6H5 benzene with S double bond or 2 times, and there is a chlorine also. Aryl sulfonyl chloride or benzene sulfonyl chloride. And if you have primary amines, say for example RNH2, if you have here, I have written an example C2H5NH2. If there is a primary amine, this chlorine will be leaving with one hydrogen from RNH2. And in this example, you take this hydrogen and this chlorine. So HCl is eliminated. As a result, these two reactants are combining like benzene with S double bond or 2 times. After that, you write NHC2H5. Just connect those two reactants. That's it. Similarly, if it is secondary amine, R2NH, then also there is a hydrogen. That hydrogen will go with this chlorine. And in this example, this chlorine and this hydrogen is leaving, and these two reactants are connecting like this. Here also HCl is eliminated. But if it is tertiary, you see R3N is a general formula of tertiary. There is no hydrogen. So that elimination of HCl is not possible. So we can say that tertiary amines do not react with the benzene sulfonyl chloride. It means when you use this reaction, we can understand the presence of primary, secondary and tertiary. Tertiary amine, of course, no reaction. But primary and secondary, how do we distinguish between the product of those two? The first product is soluble in alkali. Why? Because of the presence of hydrogen atom in the product. But the second one is insoluble in alkali. So this is how we can distinguish whether it is primary or secondary. You add alkali to the product. If the alkali, the product is like a precipitate. That product, if it is soluble in the added alkali, it is primary. If it is insoluble, it is secondary. Why? Because there is no hydrogen atom connected with this nitrogen. And tertiary, of course, no product, no precipitate. So this is how we can understand the presence of primary, secondary and tertiary. So here ethylamine and aniline. Ethylamine is C2H5NH2 and aniline is C6H5NH2. Of course, we can use azo dye test because it is aromatic and it is aliphatic. We practice this question. And aniline and N-methyl aniline. Aniline is C6H5NH2. It is primary aromatic. N-methyl aniline is C6H5 NHCH3. NHCH3. It is a secondary amine. First one is a primary amine. Both are aromatic. If both are aromatic, we cannot do azo dye test. But one is primary, another one is secondary. So in this reaction, we can go for carbylamine test. Got it. So carbylamine test can be applicable if it is aromatic or aliphatic. Whatever it is fine, but the condition is it should be primary. So these are the different distinction tests are there in this lesson amines, and there are some other distinction tests in some other lessons like in alcohol. How can we distinguish primary, secondary and tertiary alcohols? In ketones and aldehydes, we can distinguish by using Fehling solution and tolerance reagent test and all. So all those things we can discuss later. So I hope you understood this. Thank you all.